We're intrigued by the challenges posed by electric motorcycles. I'm an engineer as well as a racer, and I'm very attracted to the idea of overcoming these technical challenges to make a green bike that's still legitimately fast and exciting. We've got some really talented engineers that we've pulled in from the unmanned helicopter industry.
My day job is in aerospace engineering, develop unmanned vehicles. We've designed some really neat unmanned vehicles, for instance, set the world record for helicopter endurance. So I'm used to working in things that are high power, lightweight, involve a lot of control systems. I've also worked a little bit in the automotive industry, developing hybrid cars, both in the supercar application, but with a vision toward heavy vehicles where saving fuel makes a big environmental and economic impact.
I've done all sorts of projects in the aerospace industry. My primary background is in electrical engineering and software to some extent, so I've had a variety of experience in software and electronics, including wireless technologies, GPS, power systems, all varieties of electronics.
I'm also an engineer and I'm the rider, so that helps a little bit too, in that I can test ride and then come back and talk directly to the engineers about improvements that we need to make. Yeah, there's some formidable funding challenges in front of us because we're on the cutting edge of technology. We've got a number of partners like Oleans USA, Yoyodyne, Swift Engineering.
Swift Engineering has been around building race cars since about the early 80s, and we moved into this facility in the early 90s. And up until about the year 2000, we were primarily a race car manufacturer. Since then, we've diversified into aerospace, unmanned aerial vehicles, and manufacturing of components, high quality composite components mainly, for other people.
Swift is providing us carbon fiber composite fabrication. They're providing us with a wind tunnel.
Chip and his crew, he's got some very talented engineers working on it, but we feel there are certain things at Swift that we can bring to the party to aid him in his project.
Our whole approach to designing this bike is probably different from other teams. We have data, real data from the tracks that we're going to compete on, and we are developing the bike to deliver the same lap times as the data that we've collected from those tracks.
To use real lap data, real driving data to educate our design and make improvements. So we've already got data from some of Chip's past races. This is from Laguna Seca last year, shows breakdown of different power, how much is being used in braking, how much is being used to go up hills, that kind of thing. And that lets us size all our components, make sure we have enough battery juice at the end of the race, make sure we have the right motor, make sure we can at least match, if not beat, last year's performance. But then as we continue to race, we're going to collect this kind of data, improve our algorithms, improve our components. In a gasoline bike, you have very efficient energy storage, very lightweight for the amount of energy you get. Batteries are a lot heavier, but gasoline is very inefficient turning that energy into force at the wheel. A gas engine at peak efficiency is something like 30% efficient. In a race, it's probably more like 10% efficient. We waste a lot of energy in braking. An electric system, on the other hand, is more like 90% efficient. So for instance, the motor we're thinking of using is in the 190 horsepower class. The motor that used to be on the bike's in more the 110 horsepower class. You can see that's going to be a big performance boost. It's going to be fun to watch. The challenge, of course, with the electric is that it's hard to store all the energy you need to provide that power.
Well, there's a lot of technologies available for electric vehicles right now. What we'll probably end up using is some form of lithium battery, lithium polymer, lithium ion. Those currently have the best energy density of the technologies that are widely available out there. If we can, we'd like to get our hands on some of the newer technologies, and that may happen over the next several years. But right now, those are mostly in the lab still, and not widely available.
And the motor itself, for its power, is much lighter than the gasoline motor. The energy storage, the batteries are a lot heavier than gasoline.
We're looking at probably 150 pounds of batteries, maybe. Part of that depends on how much energy we can recover in the KERS system. Obviously, the more efficiently you can take your kinetic energy back, the less batteries you need to make it through the race.
So one of the major opportunities that we have, and also one of the major challenges, is to capture energy from the bike slowing down. Sometimes it's called regenerative braking, sometimes it's called kinetic energy recovery system, KERS, and that's one of the main advantages of our design, hopefully, is that we'll be able to capture more energy as we slow down, and that's also one of the things that could make its way as a product into the market.
Any energy that is consumed in braking in a conventional vehicle goes into heat in the brake pads or other waste energy. Any of that energy you can recover into the battery pack or through other means, save that energy up and put it back into the wheels when you accelerate again, is less batteries you need to carry.
Power curve for an electric motor is different than the power curve for a gasoline engine. Power curve for an electric motor, it can make full power, no degradation, often from 50% to 100% RPM or even lower RPM, so a very wide range of RPMs. Gas motor, on the other hand, makes peak power at one point, and that makes reasonable power only over a small range of RPMs, so you end up needing a gearbox. Another advantage of the electric motor power torque curves is that you can get that power out even at 0 RPM, or torque out at 0 RPM. You have instant on the throttle, so going from a dead stop, you get torque right away, whereas in a gas motor you don't.
Certainly a big electronics and software challenge on this bike in managing batteries, managing how much torque you get out of the motor, monitoring temperatures and other characteristics of the system to make sure everything's running safely and efficiently. There's a big electronics and software challenge for sure.
One of the places that our technologies could make it into the market first isn't in an all-electric vehicle, but in a hybrid vehicle. Hybrid vehicles require high power systems, and that's something that the racing application pushes the frontiers of.
We have people on the team to help us file patents, so our investors will be able to realize financial returns from the development and inventions that we're making. But at the same time, we're not afraid to use solutions that are well proven. So we don't want to reinvent things that have already been invented, but we are a team of people who are capable of inventing in the process of solving these challenges. Logistics plays a huge part in any race team budget, and there are 13 races around the world in 2010, as far away as Doha, Qatar. So we see each bike, between $75,000 and $100,000. So we'll need to field 2 bikes with spare batteries and a crew, and then logistics to move around to 13 rounds around the world. Green technology in general is getting a lot of exposure. We looked at this carefully, and once we had our team together and we thought we could do a good job, we announced a press release several weeks ago, and it was instantly picked up worldwide. The Isle of Man TT trial race that was done last year received tremendous exposure in the worldwide press, and so we think for ourselves we've seen exposure that greatly outstripped the exposure that we got last year racing in the AMA and even in World Supersport. So this is a great opportunity for our sponsors and partners to come on and have your logo and name affiliated with a green racing team, but a team that is delivering very competitive lap times. And our strategy is to win races on the short circuits. So this is going to be just tremendous exposure and a lot of excitement in really what amounts to a pioneering year in electric racing.
Electric